The National Electrical Code, or NEC, serves as a minimum standard for electrical installations. It's important to understand that the authority having jurisdiction, often referred to as the HJ, has the power to adopt the NEC as is, or to develop their own code based on it. However, even when a local authority creates its own code, it must still adopt the NEC as a foundation. This means that the local code cannot be less stringent than the NEC. The question of minimum conductor size, specifically whether number 14 or number 12 is the minimum, depends on the specifics of the local code. If the local code has adopted the NEC without any amendments concerning conductor size, then number 14 is indeed the minimum allowed. However, if the local code has been amended to specifically require number 12 as the minimum, then number 12 becomes the governing standard in that jurisdiction. It's not uncommon for local codes to have more restrictive requirements than the NEC, reflecting specific local conditions or concerns. For instance, a local code might require number 12 as a minimum for all branch circuit wiring to provide a greater margin of safety or to account for potential future increases in load demand. Determining the specific requirements of the local code is crucial for ensuring compliance and safety in electrical installations. The best and most reliable way to ascertain the local code requirements is to directly contact the building department in the relevant jurisdiction. The building department is responsible for enforcing the local electrical code and can provide definitive answers regarding minimum conductor sizes and any other specific amendments to the NEC. You can typically find contact information for the building department on the city or county government website. When contacting the building department, be prepared to provide specific information about the type of electrical work you are planning and its location. This will help them provide you with the most accurate and relevant information. They may be able to provide you with a copy of the local code or direct you to where it can be accessed online. In addition to contacting the building department, you may also find helpful information by consulting with a licensed electrical contractor in your area. Electrical contractors are familiar with the local codes and can provide expert guidance on conductor sizing and other electrical requirements. They can also help you navigate the permitting process and ensure that your electrical work is compliant with all applicable regulations. Understanding the relationship between the NEC and local codes is essential for all electrical professionals and anyone involved in electrical work. By taking the time to research and understand the local code requirements, you can ensure that your electrical installations are safe, compliant, and reliable. Failing to comply with local code requirements can result in fines, delays, and even the rejection of your electrical work. Therefore, it is always best to err on the side of caution and verify the local code requirements before beginning any electrical work. Furthermore, keep in mind that electrical codes are subject to change. Local codes may be updated periodically to reflect new technologies, safety concerns, or changes in the NEC. It is therefore important to stay informed about the latest code changes to ensure that your electrical work remains compliant. Subscribing to industry publications, attending continuing education courses, and participating in professional organizations are all good ways to stay up to date on the latest code changes. Firstly, the NEC provides a foundation. Secondly, local codes may amend it. And thirdly, building departments are the best resource. Let's talk a little more about conductors, since that's relevant here. Conductors are materials that allow electricity to flow relatively freely through them. The most common conductor material is copper, due to its excellent conductivity, ductility, and resistance to corrosion. Aluminum is also used as a conductor, particularly in larger sizes where its lighter weight can be advantageous. However, aluminum has a lower conductivity than copper, so it must be sized larger to carry the same amount of current. The size of a conductor is typically expressed in terms of its American wire gauge, or AUG. The AWG system assigns numbers to different conductor sizes, with smaller numbers indicating larger conductors. For example, number 12 wire is larger than number 14 wire. The larger the conductor, the more current it can safely carry. The NEC specifies the allowable ampacity of different conductor sizes based on factors such as the conductor material, insulation type, and ambient temperature. Ampacity refers to the maximum amount of current that a conductor can carry continuously without exceeding its temperature rating. Exceeding a conductor's ampacity can lead to overheating, insulation damage, and even fire. Therefore, it is crucial to select the appropriate conductor size for the intended application. When determining the appropriate conductor size, it is important to consider not only the ampacity requirements but also other factors such as voltage drop and dating. Voltage drop refers to the decrease in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for calculating voltage drop and recommends limiting voltage drop to a certain percentage of the source voltage. Dating refers to the reduction in ampacity that is required when conductors are installed in certain conditions, such as in conduit or in close proximity to other conductors. The NEC provides dating factors for various installation conditions. In addition to selecting the appropriate conductor size, it is also important to choose the correct type of insulation for the application. Conductor insulation is designed to protect the conductor from damage and to prevent electrical shorts. Different types of insulation are available, each with its own temperature rating and resistance to moisture, chemicals, and abrasion. The NEC specifies the types of insulation that are permitted for various applications. Some common types of insulation include THHN, THWN, and XHHW. THHN insulation is a thermoplastic high heat resistant nylon coated insulation. It is suitable for use in dry and damp locations. THWN insulation is a thermoplastic heat and water resistant nylon coated insulation. It is suitable for use in wet locations. XHHW insulation is a cross-length polyethylene high heat and water resistant insulation. It is suitable for use in wet and dry locations. The NEC also specifies requirements for conductor terminations and splices. Conductor terminations and splices must be made in a manner that ensures a reliable electrical connection and prevents overheating. The NEC requires the use of listed and labeled connectors for making conductor terminations and splices. Listed connectors have been tested and certified by a recognized testing laboratory to meet specific safety standards. Labeled connectors are marked with information about their intended use and ampacity rating. When making conductor terminations and splices, it is important to follow the manufacturer's instructions carefully. Improper terminations and splices can lead to loose connections, overheating, and electrical failures. In addition to the NEC, there may be other applicable standards and regulations that govern electrical installations. For example, the National Fire Protection Association, or NFPA, publishes a variety of standards related to electrical safety, including NFPA 70E, which covers electrical safety in the workplace. It is important to be familiar with all applicable standards and regulations to ensure that your electrical work is safe and compliant. Seeking guidance from experienced electrical professionals, such as licensed electrical contractors and electrical engineers, can also be invaluable in navigating the complex world of electrical codes and standards. These professionals can provide expert advice on conductor sizing, wiring methods, and other electrical requirements. Staying up to date on the latest developments in electrical technology and code requirements is essential for all electrical professionals. This can be achieved through continuing education courses, industry publications, and participation in professional organizations. By continuously expanding your knowledge and skills, you can ensure that you are providing the highest level of safety and quality in your electrical work. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a licensed electrical contractor or other qualified professional before beginning any electrical work. Remember that electrical work can be dangerous, and it is important to take all necessary safety precautions to protect yourself and others. Always to energize electrical circuits before working on them, and use appropriate personal protective equipment such as gloves and eye protection. By following these guidelines, you can ensure that your electrical installations are safe, compliant, and reliable.